I will request all the students and participants to please move in earlier classes, earlier seats.
Please come forward. Thank you. ठीक अब मैं आई थॉट कि ठीक है आई थॉट कि ये भी चलेगा वो आई गॉट इट मैं वही देखा था कि इसका सेंसर ठीक है ठीक है मैं कर लें Okay, I have it. Okay, Assalamu alaikum. I am today here for high performance computing. I will give a brief introduction about high performance computing. What kind of high performance platform you can use for energy sector and what kind of AI algorithm you can use. So the question is why high performance computing is very important for energy sector. It has been around 40 years people are using high performance computing in energy sector. For example, if you talk about Saudi Aramco, they have right now 5 supercomputers available in top 500 top 500.org website. Top 500.org website is maintaining top 500 supercomputers in the world. But right now we don't have any supercomputing facility in the Pakistan. We don't have any centralized database of power, agriculture, health sector, and this is a major concern for the improvement because we are right now working in the low cognitive level. So we have to improve it. And how we can improve it if we can go for the predictive analysis of all these things. So there are a lot of challenges for oil and gas companies that they have to reduce the CO2 emissions. So that's why they have, if we talk about approximately 9% of gases are emitted by oil and gas industry per person in the world. So they have some ethical and legal pressure to shift from normal hydrocarbon to the renewable energies and other parts. So all these things led to the main lot of data and led to the high performance computation. So we will go for that. So before going to that part, first I have shown you some examples from top 500.org, what kind of applications they are solving using supercomputing facility. They are solving for the atmosphere. For example, right now, if you see the November 2021 list, there are 19 supercomputers in top 500. Those are working for the predictive analysis of the weather. But in Pakistan, we don't have any supercomputers. So the thing is, if we go for the renewable energy, we need that data also for where we have to exactly install the things and other part. So these are the list of top 5 computers, just to mention what kind of architecture people are using. If you see the top computer right now that is installed in Japan, and that is built by Fujitsu Siemens. So the second one is in United States, that is developed by IBM. The third one is also in United States, that is developed by IBM. Third one is in China, that is Sunway Thiolite company. And then the fifth one is United States, that is developed by HPE. So today I will briefly talk about the data published by HPE. HPE is an enterprise part for HP's hardware and Packard. So they have their own supercomputing platform that is known as Cray computer. In 2002 or 2001, that was a top computer in the world by Cray. So the thing is, we are getting a lot of data from around the world, and we have some legal and ethical pressures. Those are published by HP. I got that data from HP website. So they have predicted the carbon dioxide emission will be increased 20% in 2050, and then the temperature will be increased, and we will be there will be an increase of global greenhouse emission from 85 gigatons to 165 gigaton. Now, what kind of measures we have to take? They have made some policies that in Paris they have discussed in 2100 we cannot even reduce that, but at least we should reduce it to 1.5 degrees centigrade. For all that part, for the prediction analysis and what measures we have to optimally take, we have to rely on the computation. As a single brain, we cannot solve a single as a global problem. So our objective, they have defined that in 2050 we have to reduce the carbon or oil and gas demand should be reduced to 50%, and these are all parameters that are leading towards the computational part and for optimization. So before going for that, what kind of supercomputing platform we can use to apply high performance computing in either in energy sector, in health sector, and everywhere? First, we have to understand the architecture of computer. That is a Flint's taxonomy I have shown in the slide. What it states, we classify the computers in four streams. The first one is single instruction, single data stream. And the classical computer or your PC belongs to this category. Then we have single instruction, multiple data streams. You have probably heard the name of accelerators, GPUs, where you are going for array processing, vector processing. If you think about the data from oil and gas, you are dealing with 2D data, 3D data. So all these are your tensors or matrices. Matrix, obviously, you can represent as a multiple vectors. So normally the computers belong to these categories, are very useful for the problems related to tensors, matrices, and so on. So then there is the third category, that is MIST, that is multiple instruction, single data stream. Technically, we don't have any example right now, practical example of computer in that category, and we don't have any problem that we will be solving that part. What does it exactly mean? It means we have multiple instructions that I have to apply on a single data set. For example, I have two variables A and B. I would like to apply plus, multiply. I cannot see any example, and you cannot produce the example like that. So we don't need it. But mostly supercomputing facility, they are using two categories of MIMD. One is a shared memory system, and the second one is distributed memory system. In shared memory system, we have a classical example of multi-core architecture, multi-threaded computers. And then we have in distributed memory system, we have grids, clusters. Right now, we are, if you go back and see the architecture of the top 5 computers, those all are using hybrid technology. Hybrid technology, they are incorporating accelerators, GPUs, multi-core systems. You see here multi-core systems. Okay. So for example, if you talk about the first computer, there is 48 cores. So multi-core, how you can do the programming? So you should know the architecture and how you can do the programming. And then they are connected using TOFU interconnect. So they are connected. So you have to know how you can do the distributed programming and so on. Okay. For example, here as an accelerator, they have used NVIDIA, GPU, and so on. So just to give a brief overview about shared memory system, in shared memory system, we have multiple CPUs. They are connected with some network topology to the main memory. Normally, if you purchase the computer, you have heard the name of FSB. That means front side bus. So they are mainly using bus architecture, but advanced supercomputer processors, they are using different architecture for the high performance and parallel reads. In distributed memory system, for example, I have one laptop, second laptop, one computer, second computer, and you can connect using some network topology that can be mesh network, bus topology. For example, nowadays as an example, we have Ethernet, whatever topology you can use, but there should be some network topology and you can connect them. But the thing is how you can do the programming. And in SIMD architecture, this is a classical array processors. In array processor, normally you are not dealing with control things. If condition, there are less if condition. We have more loops. We have more data, more loops, data intensive computing. So for that part, we don't have a local control unit. So we are not using CPU where we should have some control unit instead of control separate control unit. We have a single instead of uh, we have separate control global unit. We don't have control unit in all these P's. While normal PCs distributed system, we have simple processing elements and then control units. So that's how we can decrease the cost and increase the performance of array processors. So we have some test bed for supercomputing facility available at JIK. So if you want to use it, then you can contact me. So first, I will give you an overview about MIMD shared memory system. In order to do programming on MIMD shared memory systems, we have multi-core system. What you can do, the traditional way to do programming was threads or processes. Those are very difficult to scale up. Instead of using them, the scientific community has come up with an idea that we should have some scalable and high performance framework, so we can do easily. We can also do the programming in easy manner. So for that purpose, we have an open source MP, open multiprocessor framework that you can use it, and that is very easy to implement. Here you do the communication, or you can scale it using processes IDs. Then we have distributed system. In traditional way to do programming on distributed system was socket programming. For example, if I connect two computers, you have to remember the IPs and what's about the scalability. For example, if you are using this local area network IDs, and for example, if you would like to move a cluster from one network to another network, what you have to do? You have to rewrite the entire program because you have to change the IP addresses. So that was difficult to scale up. So why not we should have a simple strategy so we can easily do the programming on any network, whether the system is made of Linux system, Mac system, or Windows system. For that purpose, we have easy implementation for distributed memory system available. That is right now is message passing interface. And instead of doing the communication based on IPs, we do the communication based on ranks or process IDs. In a simple word, PVM, you probably have heard the name, but that was also good, but now it is obsoleted. So all the programmers of parallel virtual machine, that is PVM to MPI. MPI is very famous nowadays. It has two standards, and you can easily integrate with OpenMP and multi-threaded code. MPI too. So why MPI? The question is why MPI we should use, because it is standard. It supports all the platforms, and it is portable, so you don't need to modify the codes. You have same code that can run on your Linux systems, Mac system, or Windows system. And then we have over 125 functionalities available only in MPI 1 standard. So whatever you think I need it, you have to read the manual and make a call. You don't need to rewrite the entire code. You just need to make some calls. but it is easy and scalable. Why? If you learn only 5 to 6 functions, you can write down any program. You don't need to remember anything. So finally, I can say it is a right size and flexible. It depends upon you what kind of application you are solving. So because you are encountering the same function again and again, you can easily remember those functions. And now, if we talk about oil and gas companies, so mostly you are dealing with 2D data, 3D data, because no more than that. So now the question is how you can partition the data, because for high performance, you have to distribute the data. Once you distribute it, then every processor solves its own problem, and finally you have to gather the data. And then you can take some decisions and you can do some predictive analysis. So the main thing is to partition the data. So there are different partitioning methods available. One method is data partition. So we distribute the data, and then is function partition. For example, there is a matrix addition, so I can ask you to do matrix addition. There is some matrix multiplication, I can do matrix multiplication. Maybe my processor supports matrix multiplication better than as compared to your processor. So there are some data distribution. Mostly if you go for scientific softwares, either in open source or vendor-based software, all these software support these partitioning mechanism. These are built-in, you just need to select them. So based upon your configuration, you can go for quad-tree, octree method, spatial data structure. Whenever I say if you like to use spatial data structure, that means there should be the information of 2D information and 3D. 2D means you should know about the x coordinate, y coordinate. If you go for 3D, that means you should know about there will be the data about x coordinate, y coordinate, and z coordinate. There are some other configuration available. If we have a hodgepodge data available, then you can easily go for graph-based partitioning. So in most of software, you can see Mattis integration and par Mattis. What is the difference between Mattis and par Mattis? This is a single core code, sequential code. This code library supports sequential code. This is multi-threaded code. Underlying it is using OpenMP code. Par Mattis is using MPI library. So all the codes are available. We just need to use them. So now the question is why we have to go for AI. So if you are going for due to the pressure on oil and gas companies, because there is 9% emissions only due to their part. So legal issues is that they have to shift to renewable energy. Now the question is how they can shift it. So they need analysis. For predictive analysis, they have to use some AI models. For that purpose, I'm just giving you some AI models that you can easily use them. So I will just name them, and based upon your application, you can use those models. So right now you have heard the name of deep learning models. Deep learning models are not new. You can see in 1998, those are with us. These are not any new things, just simple MLP with some other operations available based upon, you can tailor based upon your applications. So you have heard about the convolutions. What is the difference between convolution layer? Mostly in convolution neural networks, instead of using matrix multiplication, you will be using convolution function. So as a computational scientist, my objective is to improve the speed of that convolution function and to improve the speed of that matrix multiplication. So normally convolution neural networks you can easily use for image processing, where you have data related to signals. Then if you have some time series data, what you can do for predictive analysis, you can just use LSTM, long short-term memory networks. So this is an extension of RNN. Probably you have heard there are some problems in RNN for the scalability. For example, if you talk about matrix multiplication, if you are multiplying again and again in iterative manner, if the data is less than 1, what will happen? After some iteration, it will go to 0. For example, if data is large, If you multiply multiple times, what it will, there will be overflow. So you lose a lot of data. So that's so to avoid that part, we have converted or come up with a new architecture of RNN that is known as LSTM. So I suggest you can use, if you have time series data, you can go for LSTM part. Then you have probably heard the name of generative adversarial network. Probably you have seen the fake images, fake sounds. For example, I can take the sample sound of Dr. Lake and then can generate the fake voice through telephone calls and like that. So that's why Supreme Court doesn't use those as a witness things. So we have MLP. You can use MLP. Then based upon data, you can use radial basis functions, restricted Boltzmann machines, autoencoders, and deep leaf networks. So now the question is how you can implement it. The best thing, you should do it to learn Python. Python is not difficult like MATLAB. This is an interpreter, not a language. Like MATLAB, what you do, you just write down A into B and then you get the result. Like that, you can easily do the programming in Python. As a engineer, not I am saying as a computer scientist, you should learn it. So there are different frameworks available and you can easily do the programming. You have the data about the energy sectors or from medical sector or from agriculture sector. You can easily do the prediction. You just need to learn these some frameworks. For example, in PyTorch, we have a deep neural networks library available. You can easily accelerate it using any GPUs. NVIDIA implementations is also available. And then there is another framework for TensorFlow. There is open source, that is an open source library. So framework, you can easily use it. Then if you go for for easy implementation, then you can go for Keras, because you don't need to go deep into the programming. You just need to configure something and you can go for Keras. And that technically is run over the TensorFlow. And you can change underlying microcognitive toolkit and Thino, whatever toolkit, you can change it. So mostly, I think personally, in my point of view as an energy sector, you just need PyTorch, TensorFlow, or Keras, either or these framework can easily work for you guys. Then for symbolic programming, we have another framework, MaxNet, another framework that is free for you for high performance compute, that is a Google Colab. You should all make an account of Google Colab. There are free GPUs and tensor processors available. You just need to select them. Whenever you write down the code in Python, you just need to select the runtime. If you select the runtime using some TPUs, tensor processing unit, they will be run on TPU. If you select GPU, those will be run on GPU. This is a configuration example I have shown you. So you just need to select it. Either you can select GPU or you can select TPU. So for more high performance computing, if you go for large scale computing, then you can purchase some licenses. In GPU, they are providing, I think, K80 GPU. That is a very expensive GPU. So now the question in energy sector, what kind of problems you can solve using HPC? We have a lot of problem in geophysics for seismic analysis, reservoir simulation, and then there is a problem, major problem for is CO2 emission. So how you can do it, how you can reduce the CO2 emission. Then we need to go for computer aided design for wind turbines, production plant, and then for material science, you have to go, you will be doing the analysis on solar cell, how you can improve the performance of solar cells, what kind of materials you have to use, and like that. And then weather modeling, that is a major concern for if you go for renewable energies, where you have to install the things, whether wind turbines and other part. And then for computational chemistry, a lot of applications over there for optimization. For example, if we talk about energy sector, we don't need to only generate the energy. We have to transform the energy from, and then you have to store the energy and you have to distribute. We have a lot of losses in distribution in Pakistan. So how you can optimize it? You have to first analyze it and then predict it. Then you can come up with some solution. But unfortunately, that part is not available in Pakistan. We are just spending the money or purchasing on smart grids and something, sorry, smart meters and something like that, where you are not even using there's all sensors values. So that picture I took from HPE, because HPE is a pioneer of exascale computing. What is the meaning of exascale? Exascale means you are going for billion of flops. So that means 10 raised to power 18 flops, floating point operations per second. So what we have a lot of data. For example, just for oil exploration, we have for oil exploration, what you have to do, because we don't have oil in normal place, what you have to go for the difficult terrains like deep sea, and so then you have to invest a lot of money over there. So what is the best solution? You just do the apply the high performance computing on the data, and there is a large scale of data. What you have to come up, you have to design the system based upon your application. So what I will do, I will design the supercomputing, high performance computing as a data intensive computing machine, so you can easily do the processing. So we don't need to only analyze the things, we have to do in the predictive analysis. As we go for the more analytics part, we have to spend more money, but more money we have to spend on HPC, then we can reduce the cost of physical infrastructures and we can reduce the cost of losses. We have to compare it. That is not too huge money as compared to the losses we are getting. Unfortunately, in Pakistan, we have loss of, as a losses, we have lost a lot of money in dollars. We are not counting that part. We are just putting those losses into the customer bills. That is not a good decision. So we should do the analysis. We should have a central data center in Pakistan, and there should be some one machine at least in top 500.org in the world. Even India has supercomputer in top 500.org. So thank you for listening me. Any questions and discussions? असल में कंप्यूटर एडेड डिजाइन में there are two types of software. One is open source. Okay, there are some vendor implementations available. So at least I have to mention that whenever you are using vendor software where you don't have access to the code, at least you should start with, you should know how you can use them. So what you have to do, you should set those parameters. At least you should know those, how you can set those parameters. So based on application, you have to set those parameters. For local optimization, if we go for distribution, obviously for that part, we have to write down our own code. So we should purchase those software or install those software in which we should have leverage that I can override those functions. Unfortunately, overriding part is not available in Pakistan. For example, if you go for power generation in even in Terbela, Mangla Dam, they are getting the data, but you cannot do any analysis part, and that's just a waste of money even. So software should be integrated with my main data center of Pakistan. That can be done using either private network. We need interface. Don't need to install the software. The softwares are available. We need integration and through some APIs. If they are providing the interface through APIs, I can do it, no problem. I can securely transfer the data. Okay, the major concern is the cybercrime. Okay, so we have to think about it, how securely I can move that data to my main server. One option is that you can easily install private network. And also the government should give the open source data so to the university, so they can do the analysis and give you suggestions. In Pakistan, the main problem is human resource. We don't have any human resource. For example, right now I am a director of International Collegiate Programming Contest. Okay, the top teams of Pakistan, those are best programmers, are directly hired to outside the country. And what resources you are getting in Pakistan? Koi like banda nahi. So that's why we are not we are lagging behind the latest technology. But if government invests something and gives some pays and try to come up with some policy that the people will be retained over here, then probably we can think about it. Even if some people are working over there, they are not facilitating it. These are major concerns. So what we can do as a consortium, we can bid for and we can talk to ministers and like that. So we come up with some policies, and so we can go for the improvement. Obviously, we cannot reduce the emission just by enforcing you should do it, you should do it, you should do it. But we have to analyze who is the culprit and why it is going there, why we are getting that part. For that part, we have to do analysis. We have the data.
As far as I know, as you said that in Tarbela and Mangla, I don't know about the Mangla dam, whether they do some analysis or not. But as far as I know about the Tarbela, they have the data, they do the analysis, and they actually analyze the inflow into the dam, into the reservoir, the surface of the reservoir. They monitor, they take the data using sensors, and even the outflow, and then they analyze what is the inflow into the reservoir, what is the surface, and what is the outflow from the reservoir. So they have huge data and they analyze the data and they monitor. And also along the canal, the Ghazi Barota canal, they have installed sensors.
Yeah,
they check the surface, and if there is any destruction or is there any disturbance, and the data is collected and then that is analyzed as far as
that is locally analyzed. I mean, if we take the data to the globe main data center, we have the whole entire picture. So we are not discussing, for example, probably I am sending the Tarbela Dam electricity to the place where I don't need it. I can get it from elsewhere, because I am sending too far to the wrong place. I am getting a lot of energy losses. So who is doing that part? No one is doing. Obviously, for the low level, we are doing that part, but the higher level we are not doing. Obviously, for more sophisticated, we have to install more sophisticated software, and we have to install more sophisticated hardware, and obviously we have to hire more sophisticated people. उस सबको consortium बनेगा, then we can solve all problems. So we have to look the entire picture, not a local picture. Obviously, in Pakistan, people are working with the local pictures and very good in research, either in the local industry. But we are not growing as a big industry. Even in Pakistan, if I just talk about the software houses, we don't have any large-scale software houses. But we a lot of, if you can see a lot of software houses in India. So technically, the problem in Pakistan is that we are not using sophisticated software in energy sector. We are not using in health sector. No software is HL7 compliance in Pakistan for health sector. We are not using sophisticated software in your industry, because we have a boss culture. We try to check and balance everything by myself. That is a very unfortunate thing. even sumoto by Supreme Court. Why? So that means there is problem with this process. ये कोई sumoto boss लेता है या Supreme Court लेती है तो मतलब मसले हैं. And how we can resolve it until we digitalize everything. So for that purpose, we should have a policy for digital innovation in all of these sectors. And there should be a centralized data analytics center so that can get the data, predict the data, and then do the budgeting part. How you are making the budget?
What the next year speak to you because they were collecting the data from all over the country.
Just ask them. They have just the data. Ask them to do predictive analysis. Show me some results. No. I have talked to them. They are saying we cannot share. If you cannot share anything, that means there is some problem with your organization. If I am fair, I will publish it. Either with money or either free. Because as a community, we can never grow until we publish the thing and we share the knowledge. That is a major part in Pakistan. We hide everything because we are doing mistakes. If I am doing mistake, we should accept it. That is a new project management technology, project management method. If you know some mistakes on me, on my side, you should correct it. But how bureaucracy is working? They are just working for the blame game. If I didn't miss, there is some mistake in the project. No, I've not done it. I've not done it. So I will do all the filing part and put it in yourself. We should accept that is a mistake because we are all human. Project can fail. We should think about the process, how we can improve it. So that is a major part. Until our bureaucracy process is not using the new agile methods, so we cannot survive and we cannot even compete the world. You just check the digital innovation of Bangladesh. We're not competing with them.
So what do you think? Why in Pakistan everything is classified? Whether it is NTDC or it is NCOC or wherever you
No, I will say something, then something will come and then, so it's not the part of we should discuss right now. But we have to raise the concern to our at least that we can do.
So why? What are the underlying reasons? Why we are not focused? Why nothing is
Okay, let's talk about the Gauri missile design. Okay, talk about the Gauri missile design. If there is a war between India and Pakistan, how much time it will take to launch an Gauri missile? A Gauri missile. Because it is not using the latest energy resources. It is using the old technology where you have to warm up the things, and so it will take 1 or
प्रोसेस करना है, मैं पेपर को इन्हें प्रोसेस करना शुरू कर दूंगा, वो 3 साल हो जाए. 3 साल में तो चीज चेंज हो जाती है. फॉर एग्जांपल इन कंप्यूटिंग थिंग्स 6 months are late. So these are the reasons. We have policies problems, we have implementation problem, everything is classified, and we are just doing blame games. We are not accepting our mistakes. For example, the bomb blast in Peshawar, anyone accepting? No. We should accept it. There is a problem in a religious culture, but politics problem we have in establishment, everything should be solved. We are just dictating you should do that. He will do it, but there will be some impact of his outcome. because he is saving himself. Whenever he saves himself, there will be some outcomes that will affect on other people. So we should sit together and come up with the policies, and as a entire project we have to think about it, not as a local projects. For example, if we talk about the idea of global projects in HEC, just see the awards. Any global project, local projects, local domain solve कर रहे हैं. अब मैं एक बात कहूँ, उसको पढ़ा भी पड़ जाएगा. मेरे I went to a conference in जो हमारे मिनिस्टर थे, एसन कहते हैं, एसन इकबाल. ठीक है, अब सीधी सी बात है, नस से नहीं है, नस का प्रोडक्ट है, कहता आपने हमें देना. कहता ठीक है, अभी चुप हो जाओ, हमें प्रोसेस फॉलो करने दो. सिंपल. आई नो फॉर AI सेंटर they got it. Now tell me their performance. They cannot retain even the professor because they are not paying up to the mark. And that will be a failure. And that is the pressure on the government, because वो topple हो रही थी and they have paid it. What's about the contract of the new SWAT? Who made the SWAT road, motorway? And that is a blame game. So, okay, fine enough. Okay, thank you. Any question? But as a whole nation, we have to make our data centers to solve the problems for energy sectors, for health sector, and for agriculture. We are an agricultural country, but we are not investing. And how we can make the budget? That is a major problem. We don't have any data. UNO is dictating us, and we do it. We impose taxes, and the problems are with our. Inshallah, we try to improve it.
Thank you so much, sir, for educating us and sharing your kind thoughts with us. Now it is now I consider it a great honor to welcome Dr. Erfan Youssef, who is currently working as an advisor in NEPRA. He will share his thoughts on optimum energy mix, present, future, and prospect in Pakistan. Thank you, sir.
Thank you. It's always a pleasure for me to talk to the students and academia. It was a learning experience to hear the Dr. Saab from GK. Yeah, data sharing is very important, and public sector should share the data, whatever is available with them, and we should be open source, and this is the reality. I'll give my perspective with regards to power sector. I take a privilege to state that no, though we don't make public the available data that in a raw form, but in terms of our booklets and our publications, we always open up the data for the power sector. The State of Industry report is published on an annual basis, whereas whole sum of the data stream that's power sector contains, and you can download those State of Industry reports from our website. You can find State of Industry reports published since 2004 on our website. Just to give you an overview of what going to be the optimum energy mix, what's the current situation, where the power sector is at the moment, how we are projecting our power sector to grow, and what will be the perspective optimal energy mix. I'll give you a short brief. I'll try to make it very simple and short, and would like to have an interactive section instead of keep talking. I would love to have more questions. Just to give a flavor, NEPRA is a regulator of the power sector, and we recognize ourselves as a nucleus to the whole sector. That's encompass Ministry of Energy, that's a policy making body, NTDC and system operator, who is the planning of the transmission network, PPIB, who is the custodian of thermal power projects, AEDB, who is the procurer for alternative and renewable energy power projects, CPPAG, who is basically monitoring market operator as settlement of energy balances. WAPTA, who does the hydropower, Pakistan Atomic Energy Commission, that does the nuclear. IPPs, small power producers, CPPs, and special purpose transmission lines as done by the private sector. So this is the whole power sector who has been running the show, was operating the whole power sector. The one thing is missing in this is the distribution companies who are basically distributing the electricity that is coming from the generation side to the end consumers. Or what's the role of NEPRA? Basically, as per our act, we have to create the balance between the investors and the consumers. How we do it? We have to ensure that whatever the electricity is provided is affordable, first of all, for the consumers. It should be reliable. And the last thing is sustainable. Sustainable is very important because we have to take care of the sustainability of the whole segment, starting from generation side, then transmission, distribution, and then consumers. This is a upper ladder, which starts from the energy costs. We are very fragmented and very curious to see how the energy cost is going up and how it is impacting the industry and in a way industrial growth in the power in the country, and overall impact over the economy that translates into the country's sustainable development. And this is an area we as a regulator are pondering more so that we can develop the power sector in a way that would contribute in the betterment of the economy. What issues we are foreseeing in overall scheme is that we have to ensure that in our system, cheap and clean electricity is inducted. Till the time this generation side remains expensive, it will be difficult for us to keep the momentum of the sustainable growth that we have seen recently. If we have to compete in the global nexus, then we have to be cost competitive, and energy being the most important ingredient, we have to be make the electricity prices lower. In order to do that, the second important thing is we have to fix in the existing infrastructure. You might be knowing that we are having a huge line losses, which are basically causing a huge impact upon the overall electricity prices, with a 17% loss of electricity from the generation till the consumer end. It's unfair to say that we can sustain the power sector on sustainable grounds. We have to fix it in a way. We have to improve the efficiencies. Just to give a snapshot, starting from the generation side to transmission distribution, how we are progressing, what are the current status at the moment. The installed capacity, generation capacity is 39,772 megawatts. This includes the generation capacity installed in the K electric area. In the transmission segment, we have a 500 kV network of length 8,000 plus kilometers, and 220 kV network more than 11,000 kilometers. The players which are playing important role in the transmission network include NTDC, K Electric, Sindh Transmission Dispatch Company, Provincial Grid Company of KP, Fatma Transmission Company Limited, and Pak Lahore Matiari Transmission Company just recently been commissioned. They're transmitting electricity from the Thar to Lahore through HVDC lines. At the distribution network, in public sector, we have 10 distribution companies. We call it ex-WAPTA distribution companies. Then K Electric, there are some housing societies like Bahia Town, DHA, and Ujala, who are basically operating as distribution companies in different parts of the country. At the total, we have 35 million consumers. If I compare it with the Australia have more than 27 million consumers, and we have 35 million consumers. And the peak demand is in Pakistan is 24 gigawatt plus. We're expecting this going to be increased with a pace of more than 5% in coming years. And I'll show the stats, how the electricity projections are going on. This is current electricity mix of Pakistan. If we go by the power mix, you can see here, the major portion of the electricity is coming from the thermal power generation, which is basically a primary concern of ours. In early 90s, our major dependence on electricity generation was through hydel, and this 60% segment was coming from hydel power generation at that time. But later on, the policymakers, they changed the decision, and they started relying upon thermal power generation, and our energy mix changed altogether, and we shifted towards the thermal power generation. Hydel came down to 25%, nuclear 7%, renewables 5%, and 1% is others. That includes the small power generation, as well as electricity coming from the our borders like Iran. If we talk about the electricity generation, again, 60% is coming from the thermal power, 29% from hydel, 7% from nuclear, 3% from renewables, and 1% from others. So basically, the problem of the story is that this thermal power generation, with the rising cost of electricity, you might be knowing that already we have reached to maximum prices of RFO, coal, and LNG at the moment. We are facing huge sum of problems that how to retain the prices of electricity down. That's why you have seen that in recently the fuel price adjustments numbers have crossed 6 rupees per unit in last month. As I was indicating, what are the issues basically currently that are causing the electricity prices to go up? As in all we know, non-indigenous resources we're relying upon, we're underutilizing the efficient power plants, like because of not managing the supply chain of LNG, we have to run the RFO and diesel. There is a drastic rupee devaluation, which is our economic parameter that has basically caused huge economic loss so far. Sometimes we have to violate the economic merit order. Sometimes it's justifiable, sometimes it's not justifiable. NEPRA being regulator take a cognizance out of that thing. We tried that the system operator should follow the EMO, but due to some constraints at the transmission level, at the distribution level, we have to violate the EMOs, which is a problem. There are some infrastructure issues at the transmission side. There are some lack of planning issues. Typical examples are the two thermal power plants, LNG based power plants. They are connected to 500 kV system, which we don't know who designed those power plants to be connected at 500 kV. They should have been connected to 220 kV. That would have supported more to the power sector. Supply chain management, we have non-firm fuel supply agreements. That's why we are facing always see that the government of Pakistan has to procure energy from the spot market. Similarly, we have to procure the crude from the spot market because we don't have long-term fuel supply agreements. There are some governing issues and long-term agreements that we have signed with the particularly thermal power generation. If you go by some power plants that were installed in under 94 policy and 2002 policy, sometimes it's always cheaper to keep them shut instead of running those power plants. With long-term contracts, we cannot terminate their contracts. We have to keep it with the liabilities. How to optimize the mix? This is an area which I would like to float before you guys, and it's, particularly the researchers and academia people and students. You should look at the remaining slides very critically, and I would like that if you have any questions, you can directly ask to me. First of all, we have to take energy as an economic measure. We should not take it as an accountant. we don't need to manage as an engineer. We have to take it as an economic measure, but we gain maximum output with minimum possible input. This is an economic parameter, and this is where the researchers can help us out to maximize how to carve out a way forward, that the government, instead of thinking as a typical accountant, should look as economic perspective and increase the viability, like it did while they were announced industrial support package. They reduced the cost of electricity by 30%. They took a burden of 1 billion rupees, and as a result, they get 400 billion rupees of return in terms of revenue collection. So this kind of economic measure we have to take. Benchmarking, we have to generate more from the with same and reduced level of energy. Likewise, we have thermal power plants. They are being utilized maximum to a capacity of 62%. We have to maximize their utilization. We have to maximize utilization of coal power plants, particularly the local power plants. We have to increase the share of renewable power generation and hydropower generation so that we can reduce reliance upon imported fuel. Yeah, please. No, basically, in 2020, government announced industrial support package. Yeah, there were two packages given during the COVID period. One was industrial support package, so that the industry should keep on running the wheel, and this wheel has continued this year as well. And there was a second package that given by the government, that the consumers can pay their bills in installments. There were two packages given. I'm talking about the industrial support package, basically, which helped in running the show on an economic parameter. Yeah. Motivation, we have to optimize energy sources and capitalize productivity. This is very important. We need not to think backwardly. We need to be realistic, but with the optics, we have to promote. And we have to look forward. We have to see the things with a bright light and have to think together how we can proceed with the better energy mix in the future. But to help reduce the production costs through economic and efficient use of resources, particularly renewable power, indigenous resources, we have to bank upon those resources. If we won't do so, we'll keep on running into doubts that how do we can run the show with the sustainability. Transpires into better gains, improve competitiveness, because without having cost competitiveness, we will never be able to compete in the international markets. Our industry will continue on banking upon certain parameters, which sorry for the interruption. If we want to do so, our industry will continue on banking upon the expensive fuel options, which turn them into being non-competitive, and our people will keep on losing jobs. Our industries will keep on running out of the country, and will be losing investments. Consumers can benefit from low energy prices and quality of products by having induction of cheap electricity. If we want to do so, consumer will always face the brink of it. Once done, then of course sustainable economic growth will be done, and that benefits can be passed to the general citizens, not in terms of reducing electricity prices only, but also by giving more job opportunities, giving more room for creating different job opportunities, and improving the standards of living in the country. What measures we have to take? This is a segment which we, as regulator, as a policymaker, as a developer, as a private sector, we have to now ponder upon. what are the challenges, how to optimize, what we have to think. Being regulator, we have to again ensure that the primary sources are available in the country so that we can meet with the requirements of the consumers. Energy planning and energy mix is very important. As during the last year, we approved indicative generation capacity expansion plan. That plan has to be made every year, and we have to make it alive, keeping in view the ground's realities. This planning should continue on, and we have to work together so that whatever generation capacity and transmission capacity is expanded is done on proper planning based. We have to ensure the energy security and cost efficiency as well. On the technological factors, we have to keep on pondering how the energy system is designed and standardized. We can see, being regulator, we have seen different configuration between the distribution companies, different standardization issues in the transmission network and the generation side. We have to maintain the standardization, bring in the efficient technologies, particularly in the industrial sector. We rationalize and automation the measures, as the doctor was saying that in his previous presentation, that we have to automate the system, we have to digitalize the system, we have to bring in more technologies. This is an area where we are working. The national electricity plan that the government of Pakistan is now bringing is categorically talked about how we can automate the overall power sector. As it will start from the generation side and it will end up to the consumer level. We're talking about all the technological interventions that we have to take, and this plan is going to roll out in 2 to 3 months. We have to improve the operations and maintenance practices. Our current practices are based upon the legacies. Our grid code or distribution code were designed in 2005 based upon the inputs taken in 2003. We're nearly 17 years past, and we are still relying upon the same. Yes, please. Yeah, basically, this is a very good question and very timely question. Yeah, the grid code has been discussed with different stakeholders. Basically, there are two eventualities that are coming in. One is we are going to open up the market for the private sector. We are going to liberalize the market. We are going to shift from the single buyer to multi-buyer system, starting from the wholesale market, and then later on we'll go to the retailer market. And for that purpose, to make that eventually happen, we had to amend the grid code, and the grid code is now revised. The stakeholders have been taken on board. The comments have been finalized. The document is available on our website for comments. If you can give more comments on that, that will be very useful for us. We foresee that by mid of April, the grid code will be revised. And see how the microgrids were envisaged in national electricity policy, national electricity plan, and how they're envisaged is this is very critical to understand. Why microgrids? The first question arises to me: why microgrids? The microgrids are essential because they're in areas where the demand is very low and it's technically and financially unviable for the distribution companies to extend their system to those areas. And if they keep on doing so, their losses will continue be at the level of at the moment are. So we have the opportunity to bring the technology. We have the opportunity to bring the investment in the private sector. The technology interventions are there. People are developing microgrids all over. Then why not to replicate in Pakistan? So the NEPRA is going to come up with a regulation. The regulation is already finalized. And in a month or so, this is going to be made public, and we'll be inviting private sector to invest in microgrids. But this will be particular for those areas which are unserved at the moment. And they'll continue, because if we go by those areas, I don't know, have you visited the Balochistan vicinities or on the central part of Sindh? They are still not deprived of this very basic electricity which we are enjoying 24 hours. And in the 21st century, if we see those people without electricity, without food, without education, this is hard to digest. But these people are living in 21st century, which is very harsh for us being custodian of the regulator. We are bringing up these regulations, and we're trying to open up the market for those people so that they can also enjoy the bounties of electricity which currently we are enjoying. See, these we are going to start with the consumer end. If military wants to install, they can, of course, ask the permissions for that purposes. However, first of all, those areas should be off grid. And there are certain areas where the military is operating, particularly in Pasni, in the region from Ormara to Gwadar. There are some areas where off grid. There are some areas starting from Jhalmaksi to Turbat. Most of the areas are off grid. If we talk about areas from Shikarpur to Sakhar and Ladkana, there are some areas which are off grid. In Dadu, we are areas where the grid is not there. Tharparkar, Nagarparkar, where the major installations of army there, but there is off grid. In Bhavalpur regime and Bhavanagar, there are some areas where army installations are there, but they're off grids. So they can always go for the microgrids. We are not going to stop them to turn on, but they have to get a license from us. At the beginning, no, straightforward no, because the overall idea is that we provide access of electricity to those areas which are deprived at the moment. If we open up the market for those consumers who are already enjoying these bounties, then the people will go on investing in these areas, and they will not go to those hard areas. We want to capture those hard areas first. In areas like Islamabad or even in Mandi Bahauddin, the people are enjoying electricity. They don't need microgrids. They need reliable electricity access, which the distribution companies are trying to provide. Yeah, actually, under the power market mechanism, we are going to set up a power data center. This data center will be operated by the system operator. System operator will be housed in H84. It's already operating. It's already gathering all the power sector data there, and this will be automated. We are working with academia as well as international donors to put up the latest software tools, who will be connecting all the market players for dissemination of information, quick information, of course. See, data need, the first challenge is to connect the whole system. Till the time this system is not connected, the data center is not there, then it's talking about again, I will take liberty of denying this chronology. There are experts available in the market. We are working with 3 energy centers at the moment. Lancer Energy Center we are working with. We are working with NAST. We are working with UT Peshawar. Even UT Texla. The people are very brilliant. They're working on very good work there. They have been continuously contributing in our whole stream. There is an integration energy planning department created in planning division, who is coordinating with all the stakeholders for research and development and optimization. The Ministry of Power is going to put up a whole sum of integrated energy planning secretariat within it, so that in future all the planning streams should be based upon integrated thing. wherein we'll talk about not only the power sector, this will be all based upon the whole energy sector cascade that will ensure each and every drop which comes into Pakistan should be manageable and accounted.
I was wondering, what about the tariff in case of microgrids? Are you going to allow the company or the owner to set it, or are you going to put some constraints over there?
Yeah, the idea is that first of all, liberate the market. Do not create such kind of regulatory things which can delay this development. With that idea, the authority decided to let the consumer and the electricity supplier to decide upon the tariffs. If they agree upon this tariff, we won't object that tariff. However, if consumer face some kind of discrimination or if issues, then of course regulator will play a role.
It's going to be variable.
It's going to
from
be
grid to grid.
yeah. Human interface, yeah, please.
To one, to break down the monopolization of the discourse, and two, to incentivize the movement of the energy mix from conventional towards renewable energy, please.
See, in 2018, when the NEPRA Act amendment came, that already has broken the monopoly of the distribution companies in two ways. First, it has segregated the wire and the supply business. As I indicated, we're going to liberalize the market. That means we're going to open up the market for the private sector competitive suppliers. We're starting with the wholesale market at first stage, wherein more than 2,000 bulk power consumers, they will be given option, rather they will be given liberty to choose their own supplier. They can go to the market. They can likewise. If I am Gul Ahmed, my textile industry is there, my load is 30 megawatt. I can talk to Angro that you have generation capacity, you supply it to me. And to supply that electrons, Anglo don't require to put up the transmission network, distribution network. Rather, distribution companies are obligated to provide wires connection to those electrons so that Anglo can easily transfer the electricity to Gulam.
Okay,
And in second way, the NEPRA Act amendment has recognized that the exclusivity of the distribution company is no more there. Licenses of most of the distribution companies are going to expire by 2023. By this, the exclusivity of all these distribution companies will be over. And now that the other players will be able to come up to NEPRA for the distribution businesses. And this is a way why we, being regulator, we awarded a license to Pahariya to distribute electricity to this consumers. Similarly, if more people will be coming on, we'll be happy to give distribution licenses to those companies.
So, sir, in your expert opinion, as a consumer in the Rawalpindi Islamabad region, what time frame can I expect? You know, that I will have options other than ISCO, or if I'm living in Lahore, what other options I will have apart from NESCO?
Yeah, see, as indicated, we are starting from the wholesale market. But for the retailers, it will take some time. I don't see this will happen. I'll be very honest to you. I don't see this is happening in the next 5 years because we have certain liquidity issues in the power sector. Till the time the distribution companies are not liquidated adequately, and we as regulator think that till the time these are not privatized, they will not be able to bring innovations in these distribution companies. And it will not be prudent to say that they will be able to provide services to those competitive suppliers who choose to supply electricity at the doorstep of the consumers, particularly domestic consumers. So next 5 years, it's not going to happen. We are going to experiment with the wholesale market from 1st May this year. This is its commission date. First consumer will be out from the distribution network will be on 30th April 2023. Afterwards, all the power consumers, they will be eligible to go out, And in 2025, then we'll be looking at how the market is going on and to what level we have to open up. We're starting with consumers having load above 1 megawatt, but in couple of years or 3 years down the line, we'll keep on reducing this threshold, and the roadmap we have in our minds in the next 7 to 10 years will bring it down to 100 kilowatt level at least.
Thank you, sir.
Yeah, natural resources, as you indicated, we have to be very cognizant towards the climate conditions. Though we are not the contributors towards the GHG emissions, our share in the GHG emissions is 0.8%, but we're the top 5 countries who are the most vulnerable to the climate changes. This calls for a very quick decision making towards integrating renewable power generation. We are already doing it. The indicative generation capacity expansion plan that I show the energy mix to you, that calls for integrating more share of wind and solar and hydropower instead of switching over to thermal power generation. Social and political influences, we foresee some kind of a social impacts, but we have to change our mindset. We have to tailor our mechanisms. We have to think upon innovations, and we need to bring upon harmony among all the stakeholders to switch over to optimization. There are certain economic reasons. Of course, we have to increase the economic productivity. We have to compete in the world. We have to be sustainable, and till the time we're not economically sound, it's harsh to say that our nuclear weapons will not be able to sustain us, our independence, till the time we are not economically sound. And we have to reach that economic soundness as soon as possible. Otherwise, Russia broken up in 1990 just because of the economic crisis, despite it had a lot of economic cars. Nuclear arsenal. So these nuclear assets won't sustain us this independence for long. We have to be economically stable as quickly as possible. As indicated, we are planning to capitalize in these resources. We're bringing in effective innovations. I've talked most of these things, and no need to repeat these things. Management standardization, interventions, we already discussed these things. Yeah, this is the cascade which we are working on at the moment. NEPRA Act amendments, there are certain amendments we are bringing in to improve the overall perspective with regards to liberalization. In 2018, we already done a lot of work on it. In 2022, there will be more changes in it. National electricity policy, this policy came under the NEPRA Act. This has already been launched last year. That requires a lot of innovations, lot of developments, calls for competition in not only generation side, but at the transmission and distribution side as well. Alternative energy policy that targets 30% of renewable power in overall installed capacity of the country by 2030. This is already in place. Now we are coming with national electricity plan that's bring up we are very hopeful that it will be change the overall scenario of the power sector. And IGSEP is a crucial document that's has been developed first time last year, and now this year it will be a composite document of generation as well as transmission capacity, and we are going to implement that thing in a very holistic manner. Policy mechanisms which we are working on at the moment, enabling the private sector investment. This is a major important crux of the thing. We foresee that, we believe that, we realize that the government has no shoot to come into the businesses. The business is the venture of the private sector. We as a public sector need to be enablers of the private sector investment. The regulator should be the enablers of the private sector investment and let the private sector to grow, to deliver and to serve the nation. We are owning the B2B projects, new business models in distributed generation, likewise the private sector PPAs and leasing model, net metering, all the stuff. As indicated, we're going to open up the market. with the CTBCM, which call for, we have named this with the wholesale market mechanism, competitive procurement. In future, we have decided that all the electricity will be procured only on, on competitive basis. That's been done in all around the world. This is what's going to ensure in future that there won't be upfront tariffs. We will discourage the cost plus tariffs. It just will be a competition. Least cost generation. Again, this is a principle we are working on so that we can bring down the electricity cost and improve the energy mix by increasing share of indigenous resources. So this is the projected electricity mix by 2030. This was given in the IGSEP document. You can see these numbers in the indicative generation capacity expansion plan of 2021. You can see that the generation from the thermal power resources that includes coal, LNG, RFO, and gas has reduced to 33%, and rest all coming up from hydel, nuclear, solar, wind, and gas. In the generation side, you can see that we are more relying upon hydel and nuclear renewables, and less likely on other thermal resources. And LNG is going to be the minimal resource, but later on after 2030, because we want that maximum electricity generation should be based upon indigenous resources instead of imported. What's the way forward for us? Energy security, market transformation, sector cohesion, digitalization, which is very important, we feel, least cost, and decarbonization. Now, the next two slides are for students. As Dr. Saab was saying that we have to learn how the new things are coming. We have to make ourselves digitalized. We know how to think like digital memory. We have to keep learning the new things. We have to show more interest in new technologies, new interventions, new researches. We have to expand our mind and stay motivated. Students, you have to stay motivated so that you can learn new things. Till the time you're not motivated, you will not learn the new things. And you will not learn the new things, then you will keep on facing the issues that the human resource in Pakistan are currently facing. As a student, when I left the university, I had no vision that what I have to be. In 5 years of my professional career, I learned that what I should be. And this should not be the way for you students. You have to learn right from the beginning what you want to be and what you have to learn and what you have to deliver in your life. There's some areas of research I have stated down where you can work upon. If any one of you are interested, being regulator, we can undertake these research assignments together. Likewise, large integration of renewable power is necessary, resolving technical constraints. This is an area which is allowing for us how to tackle the technical constraints with 30% share of wind and solar. As you people know that these are the variable resources. What steps should we take to ensure sustainability? Operating distributed grid with a large share of net metering connections. At the moment, the share of net metering connections is below 1%. But as the growth is going on, we expect that this is shortly going to be 5% more. How the distribution companies will make the business out of it, and will they remain sustainable or not? Students can help us in these areas. Role of RIs and the market operation mechanisms. GIS toolkit for renewable energy integration planning and management. Already we are working with NAST for GIS toolkit for distribution network. This is an area for the power where the ComStats people can also look at it. Electrifying remote villages through renewable energy based microgrids. This is an area, boss, you can always look at as your research assignment. Great. Sophisticated models and tools for forecasting renewable power generation. Though people around the world have done a lot of research over it, they have done a lot of activities in Pakistan. We want local solutions for the forecasting. It's easy to procure such sort of forecasting tools from around the globe, but it will be better to have a local solution. It will be cheap. Our human resources will be developed on it, we will be have local human resource working on those resources. Market access to future emerging RE applications, particularly hydrogen, geothermal, solar thermal, tidal. These are resources which are coming on. And what is your take? How to build those resources into our energy mix in an economic way? These are areas which we can work upon, and we can have a better research and development. If you have further questions, I'm available here. Or if you would like to have questions in person or through emails, through mobiles, my contact details are with your organizers. I'll be happy to respond. Thank you.
Thank you, sir, for educating us with your valuable talk. Now, I will request you all to please proceed for the lunch, and we will be back in around an hour or so. Thank you.